For today's video, we are going to find f prime of x for f of x equals to 3x minus 2x squared quantity cubed. So f prime of x, that's really just the same thing. F prime of x, that's really just the same thing as df dx. And I like this notation a little bit better because it shows a little bit more clearly what we're doing with the chain rule. So if we take this original equation here, and we're going to take the derivative d dx of the whole thing, we can now write it as df dx is equal to, and then I'll say d dx of 3x minus 2x squared quantity cubed. Now we can't take the derivative of this function the way it's currently set up because it's a composite function. So we need to simplify it a little bit by calling this inside part of the function u. So we'll say u is equal to 3x minus 2x squared. And then we can rewrite this original function and it looks a lot more simple. So we have d dx of u cubed. And this we can take the derivative of with respect to u. So if we say d du, that's easy to take the derivative of. But we can't just add a d du here. We have to actually put a u here also. So we have du dx and then d du. And this du would cross off with this du. And that would give us the original d dx that we were taking the derivative of for the original function. So what is du dx? Well, let's take the derivative of the function u that we created over here using u substitutions. So du dx is equal to 3 minus 4x. So we can substitute that in here. So this is 3 minus 4x. And then d du, well, that's just 3u squared. Well, we know that u was equal to this. U is equal to 3x minus 2x squared. So we can just take this and then substitute that into the u. And then we're also going to take this factor of 3 and we can move this out into the front. So finally, we would have f prime of x is equal to 3 times 3 minus 4x times the quantity of 3x minus 2x squared raised to the second power. And we are done.